Good evening, grade eights. I hope you're having a great week. It's a pretty hectic week with lots going on, and we are coming to the end of our culminating task, our Fractions Fest. And I've seen some great ideas and some great explain everythings being created so far. So great work, and just so you know, I'm proud of you all so far. You're really showing me that you're working hard as a class. So we're going to have a fraction review today for our unit test on Monday, and I'm just going to quickly go over what our agenda is for today. So our agenda is going to be the types of fractions, equivalent fractions, addition of fractions, subtraction of fractions, multiplication of fractions, and division of fractions. So what I'm going to do in this review is go over the basics and the strategies, some of the strategies that you can apply for your fraction questions. So I'll be going over these, the basic concepts, just so you can get a better understanding of the general strategies. And then you can take this knowledge of these strategies and apply it to various different fraction questions, like the ones we completed in class, like the examples we did in our review, our snakes and ladders game in class. Because our questions on the test will be very similar to that, and I don't want you to stress out about it. So we'll get going, and we'll start off our first topic, which is types of fractions. So we've got various different types of fractions, but very first of all, a fraction is written like so. If I have the example, a quarter. We have a bit of math terminology to go over first, so you know what I'm talking about when I'm explaining. So the number on top is going to be called the numerator, and the number on bottom is going to be called the denominator. Just pretty basic review, just so we can get clear in our heads what the math lingo is for when we're talking about fractions. So as it stands now, this quarter, the numerator is smaller than the denominator. So the 1 is smaller than the 4. So we call this a proper fraction. Proper fraction. When the numerator is larger than the denominator, for example, if we said 5 over 4, and the numerator is larger, we would call this an improper fraction. Now, to change an improper fraction into what's called a mixed fraction, we would divide the bottom here, the denominator, into the numerator. And if we did that, we would get our answer as 1 whole, and we have 1 over 4 left. So this is what's called a mixed fraction. Okay, so there are 3 types of fractions, and we're going to be mentioning them throughout our review here. We have our proper fraction here, we have our improper fraction, and we have our mixed fraction. So they're just our terminology, our terms we need as we go through this unit. So we're going to quickly look at what equivalent fractions are. So for example, if we take our example again, 1 over 4, and we look at the fraction 2 over 8, and we can see that, you know what, like 2 over 8 and 1 over 4, if I was to draw them out, they would look like so. Here's 1 over 4, and 2 over 8 would look like this. We split it into 8 sections, and 2 over 8 would look like this. And straight away from looking at our model, we can think, wait a second, they look very similar. So if we actually split this quarter model into 8s, we can see that 1 over 4 is the same as 2 over 8. And that's what's called an equivalent fraction. And to find out, or to create equivalent fractions, we could just multiply the numerator and the denominator by the very same number. If we wanted to create another one, we could say 2 times 2, and 8 times 2 equals, and we would get 4 over 16. For our first example, we multiply by 2. And we could do it again, and this time we could say 4 over 16 multiplied by 3 this time. And we would get the numerator is 12, and our denominator is going to be 48. So these fractions, we have 1/4, 2/8, 14 over 16, 12 over 48 are all equivalent fractions. If they were to be drawn like so, they would show the same amount or the same sections shaded in. So they're equivalent fractions. Our next step for review is addition of fractions, and we came up with two ways of doing. Well, we came up with 3 ways of doing it, but we're going to review 2 of the main ways, 2 of the main strategies for solving addition of fractions. So, for example, if we had, let's just undo that. If we had 1/4 plus 2/5. The first way is a way that we're kind of taught in grade 5, 6, and 7, and again in grade 8, and it's a routine that we kind of just learn and we take it as it is, and as long as we can get our answer, we're usually happy. But I'm going to show you this way, and I'm also going to show you how to visually or be able to model it and represent it visually. So let's do the way that we know first, and the way that we know usually is by using the common denominator. So the common denominator is going to be pretty much looking at the denominators here and seeing, well, what's the lowest number that both of these multiply into. So if we go up in multiples of each of the numbers, we would have 4, and we go up another 4 is 8, 12, 16, 20, 24, and for the other denominator 5, we would have 5, 10, 15, 20, 25, and we can see that the lowest common multiple is going to be 20. So we could rewrite our fractions as following, with the following denominator being 20. So something over 20 plus something over 20 will give us our answer. So now we have to look and see, well, what did we do to the denominator on this side to get to 20? And we actually can see that we multiplied it by 5. Whatever we do on the bottom, we have to do on top to our numerator. So if we multiply 5 times 1, we get 5. And the same on the other side. What did we do to get from 5 to 20? Well, we multiplied it by 4. And whatever we do on the bottom, we have to do on the top. 4 times 2 is 8. So now we have 5 over 20 plus 8 over 20, and they're common denominators, which means we can add them. So 5 plus 18 simply equals 13 over 20. So that's the way we all that's a strategy we know and kind of have learned throughout the last couple of years. If this fraction is a proper fraction, if it was an improper fraction, we would turn it into a mixed fraction, and we talked about them earlier. We're now going to look at a second way of doing it. If we want to visualize this, we could draw a rectangle here to represent our addition. So let's draw a rectangle. And we want to split it up into a number of sections. We don't know how many straight away, so let's look at our denominators of our fractions. We've got 4 and a 5. So let's split it into 4 sections one way and 5 the other. So we can split it into 4 sections going this way and 5 sections going the other way. Okay, and now let's visually just shade in what our fractions represent. If we look at this model and we want to shade in a quarter, we can see that there's 1, 2, 3, 4 sections this way. So let's shade in 1/4. 1/4 is going to be that section there. And now we look and we say 2/5. So our fifths are going to be going this way. So now we're going to shade in 2 of those sections. We'll see what we get. There's 1/5 and there's 2/5. When we're adding adding fractions, if there are areas here in our model that are shaded in twice, we want to spread out the wealth. So we don't want 2 shaded areas in one section. So if there's overlapping areas, we would put them in a box that's empty. So let's move these 2 over to some empty boxes. Let's move that one over here, and let's move this one over here. Now we just simply count up how many boxes are shaded. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 boxes shaded out of our total number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And lo and behold, our answers are the very same. So it's a good strategy to check your answer, and a lot of students have different ways of learning fractions, and they can clearly see it in either one way or the other, or both, which would be great. In our test, I may ask you to model it. If I don't ask you to specifically model the answer, you can use whatever strategy you seem fit and what works for you. Our subtraction of fractions is pretty much the same as our addition, but we just have to pretty much do the reverse of our operation. So we're subtracting this time. So for example, if I gave you this question here, and I said 1 1/4 minus let's see, 3/5. So straight away we could do 2 options, just like our addition. So let's do the first option first, and we're using the common denominator. But straight away we can see, well, wait a second, this fraction here is a mixed fraction. And we like having our fractions the same. So we like having proper fractions together or improper fractions together. So let's change this into an improper fraction so we can subtract our 3/5. So to change to an improper fraction, I'm going to actually bring this over here and have a little side note. 1 and 1/4. Change to a mixed fraction, we take our denominator and we multiply it by our whole number, and then we add what the numerator is. So I'll show you down here. It becomes 4 times 1 is 4, plus 1 is 5/4. So our 4 multiplied by 1, and then add the numerator, and it gives us our improper fraction. Okay, so now our fraction can be written as, or our expression can be written as 5/4 minus 3/5. And same as our addition, we could find our common denominator, which from the other question we saw was 20. Subtract over 20. And our 4 goes into 20 5 times. And 5 times 5 is 25. And our 5 goes into 20 4 times. 4 times 3 is 12. And if we subtract the numerators, we get 25 minus 12 is going to be 13/20. Okay, so there's our answer using our common denominator. Now, if we wanted to visually represent this, we can do so. So let's have a look. Let's first of all draw our rectangles. So we want to draw 5 quarters. So we know that's a whole plus a quarter. So let's draw our 2 boxes here. 1 and 2. We know we have to draw 2 and 2 identical boxes because we know that we have a whole for sure, and then we have a quarter as well. And if we have an improper fraction like so, the 5/4, we can draw our 5 quarters. So let's do that. Let's use our white here, and we'll split this one into quarters too. And if we shade in 5 quarters, we're left with 1 quarter, 2 quarters, 3 quarters, 4 quarters, and 5 quarters. And just like our addition question, if we have 4 sections going this way, our other fraction is 3/5, so we want to have 5 sections going the other way. So let's try that. Use a different color, and we'll split it into 5 sections. 1, 2, 3, 4, and 5, and 1, 2, 3, 4, and 5. Excuse the drawing there, but you get the idea. So let's see, we have 5/4 represented by our white shaded area, and we want to subtract, so we want to remove or erase 3 sections of 5, or 3/5. So let's have a look. If we take out 3 sections of our 5, and we'll go over this in maybe red. 3 sections of our 5 are going to be 1 section, 2 section, and 3 sections. And let's count up how many whites are left. So if they're subtracting, you're cancelling them out. So any red that overlaps the white sections are going to cancel each other out because you're subtracting. So let's count up what we have left. We have, I'll do this in yellow. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And how many sections are in a whole? We know that that's 20. So how many are left? We have 13/20. And we can see that that's the same as how we same answer as we got using our common denominator. Okay, that's subtraction of. Let's move on now to our multiplication of fractions. The multiplication and division are kind of similar, and these ones I think students struggle a little bit to show the actual model. So don't worry. For questions for multiplication and division, I will probably ask you I will give you like a word problem or a juicier problem, and you can use whatever strategy that you seem fit to answer your question. So if it helps you to draw it out, you could draw it out. If it helps you just to use the strategy and explain your thinking, you can do that as well. So we won't be asked to specifically use one method because many students learn many different ways, and I won't force you to do it a certain way. Not for multiplication and division anyway, for the longer questions. So let's have a look. One of our first rules for multiplication of fractions is that when we see this word, it's a golden word for our multiplication of fractions. When we see this word of, straight away a light bulb should go off in our head, and we should think, right, we're going to be multiplying. So that's one tip for you. So let's have a look at our question. 2/3 of 5/6. And let's solve it using, again, a strategy that we apply in our grade 5, 6, and 7. And we may be happy with it, but we mightn't be too sure of how or why we use it. So let's do it 2 ways. We're going to use our strategy and then we're going to model it. So 2/3 of 5/6. If we know of is multiplication, we can say 2/3 multiplied by 5/6. So our strategy for multiplication is actually we just simply multiply the numerator by the numerator and the denominator by the denominator. So let's do that. If we multiply the top by the bottom, or top by the top and bottom by the bottom, we would get 10 over 3 times 6 is 18. And that we can make an equivalent fraction out of that. If we divide by 2, we get 5/9. So our answer is simply going to be 5/9. We can also represent this visually. So if we have 2/3 of 5/6, we can draw it using our rectangular model again, and we'll do this so. Let's draw our rectangular model. And if it helps you, think of, for example, a chocolate bar, or think of something that you use in everyday life that you can maybe visualize a little bit better of what you're actually doing. So we're asked 2/3 of 5/6. So if you were just asked, instead of 5/6, you said the chocolate bar, 2/3 of a chocolate bar, you would need to draw that chocolate bar out first. And it would need to have a certain number of pieces in it. So to determine how many pieces we have in our chocolate bar, we would look at the denominator. Oops, I moved it again. We would look at our denominators, just like our addition and subtraction, and we'd split our grid into 3/6. So let's go 3 sections this way. Let's go red. 1, 2, 3, and we'll go 6 this way. And 2, 3. Good. So we have our chocolate bar, and we're asked 2/3 of 5/6. So we need to represent this 5/6 first. So let's have a look and see at our model how we can represent 5 sections of 6. You can see we have 1 section, 2, 3, 4, 5, and 6. And we want to shade in 5 of those sections. So let's do that. 1 section, 2 sections, 3 sections, 4 sections, and 5 sections. Okay, so now we're only dealing with the blue section of this chocolate bar because we're only looking for 2/3 of this blue section. So we really kind of ignore this section over here for now because we don't really care about it. We're just worried about our 5/6, and we're going to find 2/3 of that 5/6. So now let's have a look at our model, and if we get a different color, we could shade in what 2/3 of this 5/6 is. So if we look, we have 1/3, 2/3, 3 sections here, and let's shade in what 2/3 or 2 of those sections look like. And it's kind of unclear at the yellow. You can kind of see there's 1/3, and there's 2/3. So now we have represented 2/3 of 5/6. It's going to be our yellow overlapping our blue. So let's count that up. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sections out of, altogether, our chocolate bar has how many sections? 1, let's count it in black so you can see my counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 10 out of 18 pieces of our chocolate bar is going to be represented by 2/3 of 5/6. So we can write our equivalent fraction. If we divide the numerator and the denominator by 2, we get 5/9. You can see our answers are the same. So I hope you can understand that part clearly. It's a little bit trickier than the addition and subtraction when we go to model it. But the key thing is to understand that just visualize something that you would use in everyday life, just like a chocolate bar, and think, well, if I have a whole bar, and now I just want to find 5/6 of it, and then I want 2/3 of that 5/6. So you're splitting up your chocolate bar using our multiplication and using our visual model. Now, let's have a look at our division of fractions. There's a couple of strategies I want to use. I want to actually go through 3 strategies for our division of fractions. And this will give you the tools to pick whatever strategy suits you and your learning. So our first example is going to be the following. 4 divided by 2/3. We can say that. Let's say that in a different way. Let's say it in a language, in our English language that can kind of make sense to us if we don't think that we're math thinkers. Let's break it down for ourselves. We're saying 4 divided by 2/3. We can also say that how many times does 2/3 go into 4 wholes? Or how many times can you break up 4 whole numbers into sections of 2/3? So let's see if we can do that a couple of ways. I'm actually going to start this one by using, again, a strategy that we learn and we kind of learn it off, but we don't quite understand why we're doing it. So I'll show you the strategy first, and then I will draw a model or diagram to help understand why we do it. So straight away, we have our whole number 4, and we want to write that as an improper fraction. So we would change our 4 into 4 over 1, and we're dividing by 2 over 3. So when we're dividing, a rule of thumb is to do two things. We are going to look at the second fraction first of all, and we're going to flip it and then multiply. So if we do that, we end up with 4 over 1. That fraction stays the same, multiplied by 3 over 2. And from our multiplication, we know that our multiplication, we multiply our numerators and then multiply our denominators. And we get 4 times 3 is 12, 2 times 1 is 2, and that would be 6. 12 divided by 2 is 6. So this is a strategy, and it's a perfectly good strategy to use, but a lot of people can't quite visualize why we do this. So let's have a look using this strategy but modeling it. So we have 4 wholes and we want to divide it or see how many sections of 2/3 we can find. So let's draw out 4 wholes to start off with. So let's use blue. So we have 4 wholes. 1, 2, 3, and 4. Now we want to split them into thirds. So if we want to split them into thirds, we need to split each of the wholes into sections of 3. So let's do that first. Let's use the yellow. Let's use a different thickness. Okay, so let's split that into 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Great. So we have now 4 wholes split into thirds. And now we want to see how many sections of 2/3 can we fit in these 4 wholes. So let's see. Let's start shading in what 2/3 look like. Let's start with our red. So 2/3 of this one would be here. There's 2/3. And let's continue. Let's do a different color. Maybe we'll do black. And here's going to be 2/3. There's 1/3 and there's 2/3. And let's continue. Let's do yellow. There's 1/3 and 2/3. And let's do another color here. Let's do an orange. There's 1/3 and 2/3. And let's do another color again. Let's do pink. We have, pink looks too much like the orange. Let's do another color. Let's do a green. So we have 1/3 and 2/3. And for the final one, we'll do a black again. 1/3 and 2/3. So now we would count up how many 2/3 we can fit in our 4. So let's group them together. So I'll draw some circles around them. We have 1 group. We have 2 groups. 3 groups. 4 groups. 5 groups. And 6 groups. So we can see it visually here that we have 6 groups of 2/3. I'm going to write that down. We have 6 groups of 2/3 in 4 wholes. Or we can say that 4 divided by 2/3 equals 6. So I hope you can kind of see visually how we can divide our fractions. Let's move on to a little bit of a trickier one here, and that's 3/4 divided by 1/8. So we don't have any whole numbers to deal with, and we have to divide 1/8 or 3/4 into 1/8. So let's do it our first way, for our strategy way, and then we can check our answer using our model. So we would go 3/4, and we have to flip or use the reciprocal of our second fraction and multiply it. So we would have 8/1. And multiplying denominator by denominator and numerator by numerator, we would have 24/4. And if we divide that, we get 6. Now let's see if we can check our answer using our model. So let's draw our rectangle first of all. And again, if you're not sure what kind of rectangle to draw or how many sections we should use, always look at the denominators. And we can see that we have a denominator of 4 and a denominator of 8. So let's draw a 4/8 grid. So let's use our white. So let's split it into maybe 8 sections going this way. Okay, and 4 sections going this way. Excellent. So now let's look. We have to represent 3/4, and we want to divide it into 1/8. So let's see what we have. Let's look at 3/4. Let's shade in what 3/4 looks like on our model. So let's get the yellow and shade in 3/4. So we're going to have 1, 2, 3, 4 sections, and we want to shade 3 of them. So we have 1, 2, and 3/4. And we would like to divide that into 8s. So we want to divide this into our 8s, our 3/4 into 8s. Now, let's have a closer look and see how many sections of this box are in 1/8. Okay, so 1/8. So let's have a look. We know that this section here, is going to be 1/8 of our grid. So if we have 1/8 of our grid, we have 4 boxes. So let's count up how many times we can squeeze 4 boxes into our yellow shaded region. So let's just get rid of the black for now. Can't get rid of it. Okay. So let's see how many sections of 4 we can fit into our yellow region. So let's change the color to maybe a red, and let's see how many 4s we can group together. We have 1 here, 2 here, 3 here, 4, 5, and 6. So we can see again that 3/4 divided by 1/8 equals 6. There are 6 sections of 1/8 in 3/4. So I'll say that slowly again. Our first step was to divide our grid into 4/8. Our next step was to figure out, well, let's represent 3/4 because we want to divide that by a certain number. Then we look at see, well, what is this 1/8? What is it represented by using our model? And we can see that using our black circle here that 1/8 is equal to 4 of these boxes. And if we know that 4 of the boxes is 1/8, we want to find out how many of these 1/8s fit into our yellow section or our 3/4. And we can see the answer to that is 6. So I hope you can see that, and I hope that that gives a better for our fractions unit. So as I mentioned, there will be a review sheet for our test, I'm going to type it up tonight and I will post it on D2L, and I will also bring it to class tomorrow, some hard copies, so we can work on it once you're finished your Fraction Fest culminating task. So if you have any questions, please feel free to ask me, because I know some people stress a little about fractions. But for our test, there will be some word problems, but you just have to think of what strategy you could use, and then just apply it carefully. So thank you for listening. It's a long video, long review video this time, but I hope that it is of benefit to you and that you can listen along and help, and it will help you in your revision for your test and just in fractions in general. So I'm going to say a very good night, and I will talk to you all tomorrow.